Okay, so going back to the example we were talking about, this was, if you remember, the increased size method. Originally, actually, this is important. You know, it has details about how, you know, arrays and referencing to arrays are implemented. So it's important for you to understand this. So originally, if you remember, we had the collection array, which had 100 entries, right? And then we had the corresponding CDs that are created with each array index. So these array indices actually refer to certain CDs, right? And then when I create my array that is the double size, so when I say CD array temp and then I multiply this collection's current length by 2, since it was originally 100, I create an array of 200 elements, right? So in this case, I will have an array that initially does not have any object pointing from these indices, which is called temp. This array, right, has 200 entries, double the original size, but nothing is pointing to anywhere yet. So these are all null pointers initially. So what do I do in the loop? I say that, hey, my temp's first entry will point to whatever the collection's first entry is pointing into. So it will be pointing, this one, the first entry will be pointing to the first one. And then you will associate the second entry pointing to the second one. And then the third index will be pointing to the third CD object. So now I copied all my references, the CD references, to this new temp array. Then next, what do I do? Once I perform that copy operation, I will say, hey, collection is going to be equal to temp. So I will say my collection originally pointing to this allocated memory array space will be pointing to, instead of this, it will be pointing to the temp. It will be equal to temp, original temp, so that I have the updated collection in the new array, which keeps 200 CDs in it, right? So what happens to this? This is actually not referenced at all with any, you know, any pointer. So it just basically uses some space in the memory, and garbage collection of Java will, you know, collect this and free the memory that is, you know, allocated to this array. So in other languages such as C, what you do is that since they don't have garbage collection implemented, what you have to do is that you have to free the memory space allocated for this portion. Okay? So there's actually, when you look into this increased size method, there are two you know, conflicting goals you have. One is the memory space. You don't want to allocate more memory space, so that's why you multiply it, you know, by 2. You could have multiplied it by 10, or initially create an element, an array of 1,000 elements instead of 100, right? Why do you keep 100 CDs initially? To save from memory. You don't want to consume a lot of memory which you don't have any CDs in it, right? So that's why you start with 100, not with 10,000, 100,000 or so. So that you save the space. And at the same time, why don't I just increment the length by 1 instead of multiplying by 2? Why did I multiply by 2? I could have add just 1, 5, 10. Why do you think I multiplied it with 2?
Avoid such a same problem.
Avoid the same problem, but what's the problem? What am I avoiding by doing this? By increasing, performing, actually the overhead here that you're incurring is this loop which copies all these entries one after the other one. So this takes time, right? So you have a conflicting goal which takes time here, and then at the same time you don't want to make it so large that you spend a lot of memory. So memory and latency are two conflicting goals here. By doing by allocating small size, you save memory. By incrementing the size twice instead of just adding 10 more entries, you save time by not copying the same elements over and over multiple times. Okay? So this is the increased size method. as you see, I call this whenever I reach the current count, it reaches the length of the collection. So if my array is already full, I increase the size and then add my CD onto that array. Otherwise, I'll just skip and add the CD to the end. And we have, on top of that, we have the toString method, which is basically, printing the corresponding CD collection, number of CDs, total cost, average cost, and then the CDs printed in this for loop. How does it print? It goes from the first CD all the way to the number of CDs you have, and it is going to just call the CDs toString method and then print it on the screen. So when you look into the tunes.java file, you see that you create a CD collection, music, so you create your CD collection, which will have the array of CDs, count, and also the total cost stored in that. And you add these CDs into your collection, music, add CD, and then you give the title, artist, cost, and number of tracks, and so on. You add all these CDs one after the other one. And once you print out, you will see that 4 CDs are shown on the screen. And then you add 2 more CDs so that you print the last form of the CD collection, which will print 6 CDs at the end of the execution. So let me show you this. As you see, you have 4 CDs, and then the total cost, average cost is also shown, and then you have the CDs listed one after the other one with their costs, the number of tracks, and the name and artist and all that. And then once you add 2 more CDs, you have now 6 CDs, which lists all the details of the CDs that you have so far. Any question?
Hocam orada CD collection hafızası iki katıyla çarpıyorduk ya. Mesela her defasında exponential bir artış yapacak. İşte 200 olduğu zaman 400 yapacağız. 408, yani daha fazla memory space allocate etmiş olacağız. Sabit bir sayıyla, mesela 100 gibi bir sayıyla arttırmak tercih edilebilir mi orada?
The choice of enlarging or expanding your CD collection, as we did with this increased size, depends on the implementation. As you said, you will have an exponential increase in the size. That's true. However, you may find this not really practical. You can adopt, a different methodology in incrementing the size of the array. The usual method is either by, doubling the size, or what they do is they implement certain mathematical formulas to optimize this. Such as, as you go, you add smaller chunks at the beginning, and then you add a bigger chunk. And so there are certain methods that have been implemented to optimize this. But, this is a simple approach which you can choose something else to implement as well. I mean, there's no exact answer to that. By multiplying with 2 is an easy solution. Just how we can optimize the size. You can check how many of the added C portion is being used. So, for example, how long in time it has been used. That's something that you may check, because if you enlarge this last time by twice, making the size twice, and then you haven't used this for a long time, then that means it may not be really practical to double the size the next time. You can just add a certain amount and continue with that for a while. So that could depend on the usage of the array, but it's a sophisticated thing to implement that. So you have to deal with the timing of the arrays, and you have to consider that too. So that may not be really practical. As you know, array list is also following the same structure. If you remember the array list, I will cover that too. But if you remember the array list, when you add new items in your array list, you just expand the size of the array. Whenever it reaches to the end of the limit, it just enlarges the array list size according to their internal implementation with a certain size, right? So that is about the doubles the size. Doubles the size. In array list, whenever the size is, if all the entries are filled, it just doubles the size of the array list to ensure that next time it has enough space for the elements of the array. So when you look into the UML diagram of this application, you see that we have the tunes, the class which uses the CD collection, and it instantiates some of those CD collection variables. And you have the various, CD array, and then the count and the total cost, which is a double. And you see that you have the add CD and toString methods. And also we have the CD, which has the toString method and those, private instance variables. And you see that we have an aggregation that is 1 to n. So it uses multiple CDs in implementing the CD collection. That's why you have 1 and star. So one CD collection uses many CDs in its implementation. That's what this is referring to. Okay, any question? So one CD collection will have many CDs that's implemented in it. So command line arguments. How can I access the command line arguments? Do you remember? Or have you heard? What does a command line argument? So normally with JCreator, what do? You compile the application by clicking the button, compile and run and build, right? However, if you use command line execution and compilation procedures, how are you going to compile a Java code? So if I have, let's say, in this case, coin.java, for example, how am I going to compile this on command line? Java C will compile the coin.java file, which will generate you the coin.class file. So if you want to execute this, how can you execute on the command line again instead of run? You could execute this by Java. If you have the Java runtime environment, you can try these in your, in the runtime environment of Windows or Linux. So you have this black screen which you type and execute commands. So you have Java coin, right? Or coin.class, doesn't matter. If you execute this, this is how you execute on the command line. And command line arguments means that if you add more arguments to this, that's what command line argument is. In this case, for example, I can give 1, 2, and 3. These are the command line arguments to my coin class. So what is this going to provide? What does this provide? If you recall, let's see. Okay, this is where you can see that public static void main string args. So this string args actually indicate all those command line arguments. So when you call this this coin.class file and run it, it is going to have arguments that are passed to this method call. The main method will be called with these arguments, which is this args is going to have an array, string array, which is going to args0 will point to 1, args1 will be copied to, this is going to be as a string, right? All of them are strings. So args2 will keep 3 in it as a string. So if you want to execute your code according to these command line arguments, you can do that. This is useful in that, and in that kind of implementations or applications. So for example, I could have said here, if this application doesn't fit to this implementation well, but you can do that. if arg0 dot equals, right? And then if I say, for example, 1, right? And then you perform a certain task. So what is it going to check? If the first argument is arg0 is equal to 1, you're going to perform this task. And then if it is equal to 2, perform this task. So you can run your application based on the user's command line arguments. This is what command line argument is. For example, you have a coin that you run according to the input. So if the argument is 1, let's say you run your application randomly. If it is 2, if the first argument is 2, you run it as for example, user input. You use user input and ask the user to enter the input by the user instead of randomly generating the numbers. For example, if it is 3, you say, hey, I would like to read it from the file. Right? So you can run your code based on any one of these inputs, command line arguments, and that will run according to that. If arg0 equals 1, you will say that, hey, call the random method. If it is equal to 2, call the user input method, whatever the corresponding method is. You can execute your code according to the command line argument of the user. Probably you may not, appreciate the usage of this at the moment. You may think, why am I using this command line arguments? But normally, if you are using, scripts and writing code and running applications multiple times with different arguments, it's a lot easier to run them by using command line arguments. You don't need to go into user input, taking the user's input first and executing according to that. Rather, you can just, for example, using a shell script, you can list all these method calls, these application calls, and then it is going to execute one after the other one, in a sequential fashion without running applications one by one. Okay? So, anyway, what you need to know at this point is that command line arguments can be passed to applications, and then these are read by the arguments passed into the main method of your application. And you can access them arg0, args1, args2, and obviously you need to first check. There's another condition you need to check before this. You have to check if args, what do I need to check? Args dot length, right? Greater than 0. Obviously, if it is not the case, then you will get an error here if the user didn't enter any argument. Right? If there's no arguments, you cannot get the arg0 element at all. So, for example, this is going to run on the command line again, not clicking a button, but just typing the commands Java state eval. This is the class file, and then it gives 3 arguments: Pennsylvania, Texas, Arizona, and then arg0 will be Pennsylvania, args1 will be Texas, args2 will be Arizona. So name tag.java, let's see that example. So it's basically prints a simple name tag using a greeting and a name that is specified by the user. So it prints system out print line, and then you have system out print line arg0, args1. Obviously, these are not known to you at the moment. However, once the application is executed, you will be able to identify those values. I am not sure how this is configured here. Project. Does anybody know how to enter in JCreator the command line arguments? Options. As you can see, it gave at the moment saying that array index out of bounds exception. Why did it give that error? Because no arguments have been passed in this execution, and it's trying to access arg0. However, if you try this in a command line environment where you pass arguments, you will be able to print the name and the surname of the user, whoever printed those names on the screen. Any question? Variable length parameter lists. So if you want to use variable number of arguments to a method call, how can you implement this? For example, in this case, if I would like to take an average of the numbers that are passed as an argument, in this case 3 numbers, and then I would like to take also the average of arguments that are 2 or 5 or 6 for that matter. So if you want to have different various formats and various number of numbers averages, how can you implement that? That's the question. So if I would like to get mean to and average all these numbers, how can I implement them? The idea is to use a variable length parameter list to be able to do this. So when you want to implement this, if you want to have an overloaded version of the method, such as the average method, right? You could have average, and then that takes 2 integers. Average, that takes 3 integers, and so on. So you need to have overloaded versions of the average method with various number of arguments. How much can you go further, right? You have to have all these different implementations, one after the other one. Or as an alternative, you could define an array that takes an integer array as an input and then uses that. However, in this case, you have to create the array and store the integers before calling the method. So to provide a solution to this, variable length parameter list has been proposed. So in this case, you say that, hey, I'm going to give you a list of integers and just take it as an argument and use it. So that method will take, if you pass 1 integer, that's possible. If you pass 3 integers, that's possible. So it will, perform the task according to how many arguments you pass to it. So that indicates this is a variable length parameter. And how is it going to store the list? How do we keep track of the list? What is list is actually implementing internally? It's an array of integers, basically. How many entries you enter is kept as one single integer array in this case. So if you, for example, pass it with double average, you can call this average with 1, or you can call this average 1, 2, 3. You can call this average with 3, 5, 9, 16, 13. So this will basically, for each call, it is going to create an array of list, in this case, which has only 1 element in it. In this case, which has 3. And in this case, you have 5 elements that the array will be storing. The name of the array is list, so you can access the elements by using the length parameter of that list. Okay? So for example, you have the double average int list, which takes variable number of integers as an argument, and initially the result is equalized to 0. Then if list.length not equal to 0, if you have entered more than or equal to 1 elements in your array, then what you do, you get the sum equals 0, and then you'll go over the list elements. So your iterator, the variable that you use for the iterator is the number, and every time you add this number to the sum, and at the end you get the result, which is basically going to divide the total, actually this should be sum, not num, right? Yeah, it should be sum divided by the number of elements in your number of arguments that are passed to your method call, and then it will return the result at the end. Okay? So this is variable length arguments that you can, you can use in your implementation. So instead of integers, you could use also type of grade objects, any kind of objects for that matter. So in this case, you have public void print grades. So you have variable number of grades, which is passed as a list again, as an array. And for each grade, you can print the corresponding letter grade from the grades array, and it will just print one grade after the other one. So you can have actually other arguments that are passed to this. What's the catch here? So in the previous examples, we had the variable length argument, only the variable length argument. However, in this case, I have an integer that's count, another string, and then also the variable length argument. However, there's a catch here. If you think the implementation,
you have to give the first two parameters as integer and string, then the number of double parameters as you'd like to type.
So basically, the idea is correct. So you have to have the variable length parameter at the end, because you cannot know whether this is part of the variable length or the other arguments. For example, let's say I had something like this. So you have a double, and then a double, another variable length double. If you reverse the order, then it's not possible to understand which one is referring to which, and may create problems in implementing. So always you have the variable length parameter at the end of the declaration. So you will have in your method as the last argument to your variable number parameter. So the varying number of parameters must come last in the formal arguments, and you cannot have two sets of varying parameters. So there's only one variable number of arguments you can have in one method declaration. So you can't have two of them at the same time. You could also use this in constructors as well. So let's see the variable parameters.java and family.java. As you see, we have the private string array members, which is going to be basically the array of strings for the members, and then you have a constructor that takes a variable length argument for the constructor, which is basically going to take as many names as possible if the user wants to create with such variable strings. In that case, what it does is that basically it copies the array into the instance variable that I'm keeping as the members equals the names that is passed as the variable length argument. And the toString method basically is going to print the names of the members one after the other one, as this for each loop indicates. And when you look into the variable parameters.java file, you see that we have the family Lewis, which is going to be new family with 4 members. So in this case, it is going to create this string array with 4 members and then copy it to the members array of the constructor. And in this family Camden, you have the 9-element array, which is going to be created and copied into this family. And whenever you say Lewis and Camden, it's going to print those members of the families accordingly. Okay. Any question? Two-dimensional arrays. as we did with one dimensions, you can use two-dimensional arrays. The declaration and usage is similar. However, it's more, useful in lots of programming experiences, as you may also find it in your applications, such as, for example, if you're going to create a game that is going to be played on a, on a screen that has X and Y dimensions, such as, for example, let's say I have, what was the name of the game? No. You have this monster that is, Pac-Man. Yeah, Pac-Man. This ancient game, right? So if you have a game like this, how you can implement a Pac-Man, for example? So what will I have is that you will basically have an, table that the Pac-Man is going to roll around, and obviously, if you have an area that is, let's say, 50 by 50, right? And then within this area you have certain boundaries, right, that you can go through, and some of these are blocked and things like those. So you have various paths that you need to map into. So for each of these locations, what you have to do is that you have to indicate whether these locations are open for, passage, or they're closed, or, if you have a wall or things like those, you need to express, right? How can you express this? If I have a 50 by 50 area that the Pac-Man is going to roll around, if you needed to implement this. So you will have a two-dimensional array where in each I and j is going to correspond to a point in your table, which indicates if it is 0, it will indicate that, hey, it is not possible to move at this point. So you have points here which indicate that these will all be zeros, right? So that you cannot move along this direction. However, these will be all ones which you can move, for example, right? And then you will identify the location of the Pac-Man based on these coordinates. If the user presses the right arrow button, right? In that case, what you're going to do, you will evaluate the current position, and then you will evaluate the right position, which will be, for example, you will increment the column of that. So, for example, if the Pac-Man is currently I and j, the next right arrow will take you to I and j plus 1. So what you need to check is that you need to check the arrays, this point, whether it is a possible to move location or not. If it is not possible to move to that location, you will say, hey, you cannot move there, and this arrow movement will not result in any move. However, if it's possible to move, it will move to that location, and then you will update your Pac-Man's new location. Similarly, you have to use this array to find out your monster's locations. Let's say there's a monster here, there's another one here, and so on. So they will, find out the distance to the Pac-Man and then move according to that. So you will write your code according to that, and you will design it, right? So this all involves in arrays. You can implement this using an array. Also, for example, if you're implementing graphical user interface components or graphical implementations, all of them will deal, two-dimensional arrays which will store information regarding a pixel, or even three-dimensional if you have multiple colors that are associated, such as RGB, and you will use, for each color, you will use a set of bits to represent it. So again, coming to the multi-dimensional arrays, it's implemented in many different applications and programs. So how we declare that? Basically, adding one more bracket to our declaration of the array, and we initialize the number of rows and number of columns to our array. In this case, we will have 12 rows. The first indicate the rows, and then the second one indicates the columns. And we will have 12 rows and then 50 columns in this declaration, so that we have arrays indicated. And then you can access those individual array elements by calling the corresponding indices of the array.
So, how can you prevent moving diagonal in that game?
Moving diagonal, basically what you need to do is that, if you allow only move for certain up, down, left, and right, basically you will you will limit the movements for the user, right? That's the first step that you may want to use. Otherwise, if the user is allowed to use diagonal buttons, then it doesn't make sense. If you allow the diagonal button, but at the same time you don't allow diagonal move, it doesn't make sense, right? So it's not. Basically, what you will allow is you will just allow these arrows to operate based on the moves. When you look into the table, if you want to create a table, you will use this representation. If you have table 5, it is going to give you the integer array. So this is, once you have a two-dimensional array represented, once you say table, it will give you the 2D array, which is the two-dimensional array. If you say table 5, what does it give you? So I declared my table as in the previous example here. So let's say you have an int, and then I say this one table, and I have new int, and for example 6 by 10. Right? So if this is my declaration, and then I have table, what is it going to do? It's going to basically create 6 rows and then 10 column array, two-dimensional array. How is this going to be represented? I will basically have a 6-row integer array. 4, 5, 6. And then on each row I will have 10 element array. Right? And so on. So when you say table actually refers to this, which is basically an array of arrays. Okay? Array of arrays of integers. So in this case, when you say table, it refers to the two-dimensional array. When you say table 5, it means table 5 is this one. So it refers to the array of integers, that whole array with 10 elements. If you say table 5, and in this case 12, we won't have 12. If you say table 5, 9, it will go all the way to the last element in the 2D array. Right? So that's how internally what you will get. In this case, you will get an integer as a result of accessing that two-dimensional array. Let's see the 2D array and soda survey examples. If you see the 2D array, basically, let me compile this. So as you can see, what does it do? It starts from 0 and then goes all the way to 9, and then it starts from 10 and all the way to, so it prints 5 rows of numbers from 0 all the way to 49. Basically, as you see, it first loads the two-dimensional array with values. How does it load those values? It multiplies the current row with 10 and then adds the current column. So it starts with row 0, row table.length, and then table row.length. Do you see the difference here? This is important. So whenever you want to see the size of see the number of rows, what you see is that, what you apply is that table.length. So now you get table.length. So it will give you, in this case, 6, the number of rows. And then if you say table row means, in the first case, it's going to be table 0. So table 0 is this one, right? Table 0. Table 0.length will give you 10, which is going to be the number of columns. Okay, so note this distinction. Table.length will give you the number of rows. Table row.length will give you the number of columns. Okay, and then for each row, and column combination, you assign the corresponding entry 10 times row, added the column value, whatever that is. So it's going to print the corresponding value, store the corresponding value, and basically you print them in here using again a two doubly nested for loop with rows ranging from 0 to table length, and same thing, table row dot length, and you print the corresponding entry. Okay. Any question? So if you would like to add a third dimension, how is this gonna look like? This picture, if I have a third dimension. So if I have, let's say, 10, 6, 10, 2. So it's like a cube, but if you consider this representation, it's going to be messy, but just to note, from each of these entries, right, you will have another array which is composed of 2 elements, and so that you have, this kind of representation. To access the length of this, what you will use is that, as it is done here, table, row, dot, and then you will use the next column and then dot length, right? So you have to both use row and column and then the length of the thing. So if you go into the SODA survey, so this is what SODA application looks like. So you have, maybe I should open the code first. So you have an integer, 2D integer array with corresponding scores. Basically what it does is that it takes users' scores for each soda type. Soda is, Coke and Fanta and, Uludağ, all that various brands. For each soda, so you have 4 different sodas, and then you have 10 people who tested these and gave, points to individual sodas, and then they try to come up with an average of the soda values, and then also for each person's average at the end will be printed. So basically this is what is done, and as you see, they get the average for soda 1, 2, 3, 4, and then person 1 all the way to 10. Whatever they gave as a point will be averaged for individual sodas, right? So this is the application. If you go into the application here, you see that you declare the arrays, note the way it is declared. So for each row, you have another curly brackets indicating that row, and for this one you have the another curly bracket. So if I have, for example, a 3-dimensional array that I would like to initialize, basically I will follow the same path, same route, and just use, for example, for this case, what you will do is that you will basically have another curly bracket inside, so that you will have something like this, and you have the values 2, 3, 4, let's say, and then you have another here 3, 4, 5. So basically you will have 3 levels of curly brackets indicating each level for individual cases. So in this case I will have 2 entries within the curly bracket, and then next one I will have, let's say, 1, 2, 3, and then 5, 6, 7, and I have. So how does this initialization will look like? Int, and then I have, let's say, t. How will this look like? So basically I will have 2 sets of these, right? The first dimension will be 2, and then I will have, within each one I will have 2 also. So the second dimension will again be 2, and then the third one will be, since I have in each one of them I have 3, the third dimension will be 3. So if you get the lengths of individual of these dimensions, you'll get the values of 2, 2, and 3. So you can initialize using this kind of initialization method. Any question? So coming back to the soda example. So you have the initial values, and then you have constant sodas and people, how many sodas you have and how many people you are testing. And you see that you create the corresponding soda sum and person sum. For each soda you will have one entry. For each person you will have one entry, so that you create these arrays. And what you do next is that you collect the soda sum for each soda and for each person. And then using these values, average the result at the end. If you look into the for loop, you have int soda equals 0, and then you go all the way to the number of sodas. And for each person you start with 0 and go all the way to the number of people you have. And you get the soda sum, soda, scores soda person, and then you get the sum for person by adding the corresponding person entry for the specific person. Okay? So at the end of these two loops, you'll get the sum values. And then what do you do next? You basically print the soda averages from 0 to all the way to the number of sodas. You print the average by getting the sum of the soda values divided by the number of people. Similarly, for the person averages, you get the person sum for each person and divide it with the number of sodas, so you get the average of the person's grades. I will go over this on the next lecture again, and I will probably extend it a little bit further, so if you want to go and review this, it will be good for you. See you next time.